Okay, stretch it out. Stretch a little more. Alright. Good night, everyone, for another episode of Dan Does Data. Tonight we're doing kind of a new series on calling the bare minimum. Sort of the bare minimum you need to learn to do something, whatever that something is. And tonight, that something is going to be how to use Matplotlib. So you've probably seen me use Matplotlib in the stream for various things. I just want to go over like the absolute minimum you need to know to start using it. And in the case of Matplotlib, like to actually get a lot of damage out of it. Because there's all kinds of things it can do, all kinds of incredible things it can plot. You can make absolutely gorgeous, pretty pictures. I'm not going to go into all that. I just want to do two simple things. Show you how to plot basically a scatter plot, which is sort of this first image here, and a heat plot, which is kind of like this image here, but not exactly. As always, you sort of need to start with how the heck do I install Matplotlib? You go to the website, they show you, give you a nice little link. If you're on Ubuntu or Debian or pretty much any Linux, chances are it's already being compiled as a package you can just install. So you can do sudo apt-get install python-matplotlib or python3-matplotlib if you're using that. Or if you're using like Anaconda or something, it almost certainly already comes with. If you're on Mac, you can use pip. If you're not on Mac, you can also use pip. If you're on Windows, I can't help you. It looks like pip. Pip is what you have to do. I already have that, so I'm not going to go through how to install it. But that's something that you can do. If you really want to install it from source, for example, to get the latest and greatest version, you can absolutely do that. I'm not going to go through that because I find that I already have a nice system, and I like the system that I have. The defaults suit me just fine. So, without further ado, let's get into it. So if you want to use Matplotlib, you just need to import matplotlib.plot as something. So as PLT is sort of standard. Let's do that. And I got IPython on the left. I clearly matplotlib dot, is it .plt? See, this is, you'd think I'd remember something so simple. Import, is it just import matplotlib? Maybe it's just import matplotlib. I feel really dumb. Plot dot, no. Man, now I feel real dumb. Oh my gosh. You think I would have this business down. Let's do what you normally do. You go to the examples and try to learn from the examples. That is the easiest way to do this without trying to get hung up on things. Just learn from the examples, check the tutorial, do other things like that. I am really tempted to just click a random one of these that's not an animation or anything else fancy. If you're just doing a bar chart, for example. Flypot. Okay, that's the magic. I knew that. So import matplotlib.pyplot as PLT. It's a pretty standard thing to do. And now if you check out PLT, you've got all kinds of options. These are all kinds of different things you can plot, ways to mess with your plot, all kinds of wacky stuff. What I want to show is really just plot.plot. And all this does, well, this is a very generic interface, I guess, but it basically does a scatter plot. In essence, let's make a little bit of data. Let's import numpy as np as well. And let me just make a little bit of random data. Let's call it x. numpy.random.rand. numpy.random.random. Give me 100 of those. So we got 100 numbers from 0 to 1. That's all we got. And if you want to plot some numbers with lines connecting successive numbers, you just have a list plot plt.plot of x. And you're wondering what the heck happened. Nothing showed up. You just got this little blurb that says, like, yeah, I got a lines object. So if you are in like an interactive Python session, unless you want to say plt.show every time to actually get the images. Oh, Rick, you're here and you're trying to do this on Windows? Oh man, that is... Just open up a VM. Or like use Sage Math Cloud. I would never try this on Windows. So unless you want to type plot.show every time, which I don't. I get real tired of that. Oh my gosh, does it not release? Ugh. That's terrible. Kill all Python. Kill all IPython. Oh my goodness, I've never had that happen before. Alright, there we go, we got it back. Yeah, unless you want to deal with baloney like that, just say plot.ion so that when you plot a figure, it automatically gets created. Boom. Let's try this again. Boom, look at that, there it is, brand new. Fantastic. And you don't have to deal with any of that silliness. And you might say, alright, I don't really want all those lines because I don't know where I'm... You know what, no, you probably do want the lines for something like that. The next most obvious thing you might try is, well, I want to plot like y versus x. It's a very traditional scatter plot. So let's make another bunch of random data. So x is random, y is random, nothing fancy going on here. You might say, all right, show me y versus x. So you plot x, y, and it does the right thing. And you might say, that is not what I wanted to see at all. There's lines crisscrossing all over the place. In this case, we didn't actually care what the order was of our input coordinates. And sometimes you do. Sometimes you might actually care what the order is. It might matter that you go from this to that to the next thing to the next thing. But for a lot of times, you don't care. And so you can change the plot marker. And so you put in an O, and then you get the actual dots. And now, oh, okay, but now we filled in this like grid of little dots. Depending on what you want to plot, this is probably like half the things you'll ever want to plot. Those two things are there. Boom, 10 minutes. We are on a hot streak. What if you want to plot, you know, a couple different things? So that's x and y. Let me make something else. Let's go numpy.arange 100. Divide at random dot, let's divide by 100. There we go. And let's do that. Yeah, I like that. I like that. So I'm just going to make some data that's moves up from 0 to 1, and I'm going to add a little noise at each time. They're still basically random. You see how it goes from very small to about 1? You might look at this and you're like, this is kind of hard to tell that. It's not super obvious. Well, but if you go plot.plot w, oh, now it's really clear what the heck is going on. It starts at about 0 and goes up. If you wanted to do a linear regression, you could draw the line to fit this. That's the difference between trying to look at it like this, just looking at it, where it's all in scientific notation and other stuff. Hang on. Seem to have wrecked my scheme there. That's the difference between like trying to read all this scientific notation, which as a human being is horrible to do. Yeah, I can see that it's all between 0 and 1, and like making it obvious what the heck's going on. You say, all right, well, y versus z, and you're like, all right, that's interesting. Here, like, it's not all bouncing around all over the place. It's more or less bouncing forward. So that's something that might be interesting. Well, what if I care about w and I care about z at the same time? How do I plot both of those? So you can plot w, and you can say, all right, I want w to be, I don't know, green lines. And then I think you can get away with plotting z as blue lines. So G stands for green, B stands for blue. Yeah, there you go. And now you see the blue. No, actually, I should do that in the opposite order. I should do blue then green, because it defaults to doing blue and then green. You'll see in a second why that is. There we go. So blue represents our W's and green represents our Z's. You can see, alright, these things are basically following the same kind of pattern. You might be wondering, you do this plot, what happens if you plot something else after it? Let's find out. And it plots it on the same line, which is interesting. And you know, it's like, oh, why is it all squished over there? Well, that's because these are all between 0 and 1, whereas this is going from 0 to 100. So this is about 1% of the space here. And you can zoom in by clicking this little zoom to rectangle business and get an eye on it. Isn't that interesting? Let's do one more thing with this plot. I've only killed 10 minutes of this. I'm probably not going to fill a whole hour of the bare minimum of Matplotlib that you need. Let's say plot.plot x comma y, and let's mark it with circles, and then w comma z. So we're doing two scatter plots of y versus x and z versus w on the same plot, and let's mark that with x's. I like x's. And now, you know what? Those x's are really not good. X's were not a good idea. What is a better idea? Can I do capital X's? Is that bigger? Nope. So there's a certain limited set of formats of strings you can do in the format strings. You know what? They can both be circles. They're different colors. It's fine. So as you can see, the blue here is like, oh yeah, it's basically totally random. In the green, oh hey, there's sort of an obvious relation here. Whereas, again, if you just look at, well, let me look at x and y. Yeah, those are numbers between 0 and 1, and w and z. Why is w the dumb one? This I don't know why w is plotting, showing that way. Like, yeah, if I look at z, like, oh yeah, it's increasing generally, I can tell that. But it's not 100% obvious, whereas when you do this, it's obvious. That's the key. This physical representation is very near to the logical representation. They're very, very close to each other, and so it becomes clear what's happening. You could infer that the data has been generated somehow like this, if that's what you were trying to do. Let's go back to adventurous colors. I like those. So that's the scatter plot. There's 100 million more things you can do with that. Of course, you can change the axes, you can add lots of cool labels, you can change the colors, all kinds of wacky stuff. I guess you can do one thing. Size equals W. I think you can do this. No, not size. I think it might just be S. You can change the size of these little markers too, which just blows my mind. Alright, maybe not. You can do it. I don't remember offhand how to do that, because that's not the bare minimum. That's a little bit more than the minimum. That's not something you need to know how to do until you, like, literally need that. And again, you can make this lines. You can do both. Boom, boom, boom. Sometimes you care. Like you're walking around in a space and you need to track that. That's what matters. If you want lines and dots, pretty sure you can do that too. Boom, lines and dots. It's like a little constellation. Cool. Alright, that's like half of everything you need to know about Matplotlib. The other half of everything you need to know involves something called heat maps. So let's make a random matrix. NumPy.random.random of, I don't know, 10 by 10. Can I do that? Not like that, I can't. 10 by 10. Boom. Already this is large. And you can see, alright, we've got a random array of 10 things. Sure. Let's make another one. A range of 100 divided by 100. But then we're going to reshape that into a 10 by 10 array. There we go. Range. A range. Almost got that. There we go. A, B. And we're going to add a little bit of noise. Random 10, 10, nope. 10 by 10, yes. Divided by 100, divided by 10. Just so it's a little bit of noise. There we go. You do it, you didn't like that random seed, try again, get some more stuff, do whatever you like. So the question is, what does this actually look like? How do you can't just plot this. I'm pretty sure you can't just plot that. If you said plot.plot of B, or A, if you said it properly, it plots each row. Maybe this is what you want. Maybe this is something useful. You've just got all your data in one matrix. You can get a nice little row like this. And it cycles through, I think, 7 colors. So you notice there's 2 blues here. The lines aren't very thick, but there's a blue one here, there's a blue one here. Those are 2 distinct rows. You can change the colors. I have generated many more colors than this, and I've tried to find colors that are visually distinct, and I went down a whole Wikipedia page of how do you compute the distance between colors. It gets real nasty. But that's not really that helpful if we're trying to figure out what the heck's going on. I mean, you can plot them like this too. You sort of get a sense of, all right, they're increasing, and each one is in different places. But what you really might want to do is look at the array itself. But you might want to say, all right, I just want to pretend each one of these elements of the array is a pixel, and however big this number is, make the pixel that dark, or something like that. And you can do that using Pcolor. And if you put in B, ding, now you get that. Note that 0, 0 is down at the bottom here. And that's, of course, the top left of what the array actually is. But this is a nice little rainbow. You should see stripes at a slight incline over here. Because, of course, you start at 0, 0, you increase, and then you go over to the next row and you increase, and so on and so forth. And there's a little bit of noise in here too. This is this now gets you 95% of the way of what you want to do. Again, you can add a little legend and make cool things look pretty, but if we're just trying to understand what the heck is going on, you'll look at this and you'll say, aha, there's something happening here. And so a plot like this, there's clearly just, it's increasing, and there's some noise. Whereas if you looked at, I don't know, A, you would say, this looks like, I don't see anything here. There's nothing interesting. There's different values. There's not an obvious way to see what the value is in these. But I mean, getting the exact value isn't what you should be using a plot for. You should be using a plot to get a visual, quick summary of what's going on. And you just say, oh, there's a lot of orange. This looks like garbage. Are you colorblind maybe? And you don't like lots of colors? Well, change the color map. Say CMAC equals plot.cm.hot. Boom. Now everything is from white to red. Actually, let's do this on B. That might be a little more clear. Yeah, there we go. So this is white hot. This is the center of the sun. It's just dark red. It's not actually all that hot. So that might be a little bit better for certain things. That makes more sense. Sometimes you just want grayscale, because maybe you're looking at an actual grayscale image. Same kind of thing. White hot, or white is high, and the black is the smallest values. You say, but wait, I don't want to actually I want to look at my matrix like my matrix is. This is A. I'd like this position A to be right here. Alright, well that's fine. You could say plot.matchshow A. And then basically this just reorients your labels and squares everything up. That's all. Not right. Nothing fancy, not crazy. You put this one over here, and you come on down to the right. Let's do that with B, just to demonstrate. Now it's clear what's going on. You start at very low numbers. You are increasing as you go right. Go on to the next row, increasing, next row, increasing, next row, increasing, so on and down forth. From the blues to the indigos, to the yellows, to the reds. I believe it's always blue to red. Again, you can almost certainly mess around with that. You can do lots of other things. But this is, again, just the bare minimum of Matplotlib. If you can plot some 2D array like this, and maybe this array represents, I don't know, farmland and like crop yields, and you'll see, hey, this region over here has great yields. This region over here, not so great. Why is that? And then you're going to have to dig in and be like, oh, well, the soil acidity over here is terrible, and over here it's pretty good, so I need to fix that. Whereas if you're sitting here trying to look at using print B, it's going to be a lot harder to suss out. Even if you could get them to all print on one line here. Let me print B times 100. Can I do this? Is this something I can do? Nope. But I can say numpy.array of dtype equals int. Yeah, there we go. It might start to become more clear if you print it like this, but it's not 100% obvious. I see a lot of 4s and a lot of 8s, and they're like, oh yeah, it's getting bigger. I would probably do this first, in all honesty. Doing any kind of machine learning, data science, yeah, I'm going to print the data first. But then I'm going to plot the data. So that is the, as I said, the bare minimum. I didn't know that I had an hour of things planned, so this is a perfect time for questions from the audience. Plot.cm.high. Just to have a demonstration of these are all these things. So that's like 15 lines worth of stuff. Just to make very simple, not complicated. This will go a long way in your data science career. You might say, this thing is interesting. Plot of B0. Well, you know, that doesn't really tell you that much. There's something going on there. You're like, let me look at the next one. It's kind of higher at the end and at the beginning there. You might say, you know what, let me just plot all of them. Oh yeah, those are all going up. That's a lot more clear now. Whereas with 1 or 2, that wasn't as much. You might say, alright, well, what about the transpose of that? No, that looks more or less flat. Doesn't actually go up or down too much. Because now you're going down the... Actually, wait a minute. Does it plot down the columns first? Well, that's curious. I bet this is the row, because it's increasing slightly on each one. Check it out. That's a little less than 0.8, a little bigger. 0.6, a little bigger. 0.6, a little bigger. 0.4, almost 0.6, yeah. Each one of these is a row. This being the first row, then the second row, then the third row, so on and so forth. When you plot it normally, it plots the columns. This is a column, each one of these. So when you simplify, question from the audience, when you simplify a data set or compress the data, will the graph show the information with less detail? So if you've got a ginormous array, let's make a big array. That's a good question. What do you do when you've got a lot of data? So if you've got a lot of data, dot random, let's do a range still. I like a range. Like, I don't know, 100,000 data points. Yeah. Plus 100,000 divided by 10. That's 100,000 data points right there. We just say plot.plot on those. Let's take a look. So, as a line, you're cramming a whole lot of data points into a small visual field. So this looks like it's super full. So the first thing you might say is like, I don't want to see all that. Show me just the points. IPython 3 exits when your plot closes? That does not happen to me, Rick. I don't know what you got going on. That's a mistake. Yeah, definitely. I don't do data science in Windows. I cannot. I'd go crazy. Like, Excel is very nice. This is still... So you might zoom in. You might say, what's going on? Okay, now you're getting somewhere. Now there's some things filling up here. You might also try an even smaller point, a period. I think that might be the smallest one, smallest built-in point you can get, and then you can get a sense. Aha, there's a whole bunch of little guys here. And you get this nice little stripe. This might be some country's flag, I do not know. So yes, it does become difficult to see what the difference is. Let's play the same game with this. Let me think. If I got 10,000, that's 100 times 100, right? I need more. If I've got 1,000,000, that's 1,000 times 1,000. That should be fine. Yeah. And then if you do plot.pcolor of B, this might take a little bit of time. Let's see. Yeah, it's turning the crank, turning the crank. There's a million things it's got to put together. Use Pcolor. It sort of does this direct and it tries to render every single pixel. I may ruin things here. We'll see. This really better not crash my machine. It's a friggin' just 1,000,000 points. It's not that many. Yeah. So that's a lot. It doesn't like that. What you can do instead is Pcolormesh. Just a different call, plot.pcolormesh. And I believe this doesn't try to plot every point perfectly. You're just going to get like only the images that are actually obviously visible. And so now you've got this really pretty rainbow. This kind of a slight dithering from the blue to the indigo. I guess you kind of skip this kind of greenish in the middle. Maybe you skip green. Honestly, I prefer that. Green, I don't know if it's something with my eyes, just the way human eyes are. Like the greens all tend to wash together. Maybe that's even what's happening here. But it's like I can clearly see blue, indigo, yellow, red. Up to the really dark red here. And if you want to zoom in on a particular feature, or a particular region, take a look at this. And you know, here it's like, oh, it's a little more yellow here and a little bit more red here. It's not as clear what's going on. Oh, what is this? I don't even know what I clicked. Zoom to rectangle. Configure subplots. Yes, you can also plot multiple things at once. Like have a little plot here, and then a little plot here, and a little plot here, and a little plot. I'm not getting into that right now because that's not the bare minimum. That is more and beyond that. But Pcolormesh though, that is something you might need if you're plotting a lot of things, and that's 1,000 by 1,000. That's not even that big. Not even that big. I believe there's also plot.ImageShow. Yeah, and you can give an array-like thing. So if you've got a color image, you can do that. So if you've got this B, and you've got something similar, so let's change this to B. No, change this to red. R, G, change that to B. And you're going to see why I am naming them suggestively. So all our guys are 1,000 by 1,000. So ImageShow is worth knowing. So you got Pcolormesh, you got ImageShow, which is lets you plot an image-like object. You can save the plot results? Yes, you can absolutely save the plot results. I will show that in just a second. Array-like, shape, whatever. Alright, so let's make our image equal numpy.zeros of, what kind of shape does this like? And then 3, okay. It's going to be 1,000 by 1,000 by 3 for 3 color channels. And then we'll say that I of everything, comma 0 equals R. And then green, and then blue. Just that simple. So let's stuff that in there. So I is this monstrous kind of triple array. Or, you know, this is the red, green, blue channel. This is all the red, all the green, all the blue, plotted as though it's RGB, actually. Isn't that fancy? So you can see, oh yeah, the more reds are over here, and then by here it just kind of washes out. Again, this is ImageShow, so 0, 0 is down here. There's this region where you can sort of you slowly get above the noise, but by the end the noise is dominating again. That's interesting. Alright, so you can save the figure by clicking this little save icon. And it opens a little diagram. You can save whatever you want to save. I'm actually not going to do that. It's like PNG, lots of other stuff, lots of options. If you're writing a script, you can also create a figure object and save from the figure and do all this other really great stuff. But again, that's for interactive data science use. That's not generally something I do. If I'm saving a figure, I'm going to plot it all nice with all the really nice axes and other things too. I might even make the plot and then touch it up later in something else. But this, I would say, this is the bare minimum Matplotlib that you really need to know. It's not complicated, but this will get you the information that you need. This will show you, in a sense, what's going on in your image. Or like, aha, yes, clearly I'm dealing with this. So, I think that's all I really want to cover. I understand that it's only a 30-minute stream tonight, but that's okay. Sometimes we run over a little bit, sometimes we crash the system. Tonight we just happen to cover everything a little bit quickly than other possibilities. So I want to thank everyone for coming out tonight. If you have any other last-minute questions, get those in quick, or leave a comment on the video, leave a comment on the Reddit. I think I posted this to /r data science, or send me an email. I always like getting emails from fans. One more question. Use Matplotlib but didn't like it. You're having problems and need to label some data. Oh, glad you enjoyed it. I guess that wasn't a question. So I'm glad you found that helpful. You can even like label each and every data point. Oh no, that's not what I wanted. You can label each and every data point. You can put sort of arbitrary things. You can put the legend in. But that isn't what you need to go over. Tonight is all about like making this obvious. There's got to be a cool way to like make this literally draw constellations. This is just what this reminds me of. That's something I need to look into. All right, that's all I got for tonight. So again, thank you everyone for coming out. I am going to be off for the next 2 weeks, taking time off for the holidays. I want everyone else to have a safe holiday, New Year, and everything like that. And we'll be back after 2 weeks off. So don't forget, stay safe in the data mines. Have a good night.